Good morning, mathematicians. It's time for us to do some math. It's time for us to do some math. I don't know what else to tell you. We're going to do some math. But what math will we do today? I don't know. Do we go back and look at some more group theory? One of the authors, hello, Kostaka Corey. One of the authors I was looking at yesterday in one of those papers that I said seemed really interesting, actually, is an author or co-author. I don't know if they wrote it alone, but of a annals paper, resolving some conjecture in graph theory. Group theory. Some Brauer height conjecture. So it's pretty cool. Why don't we check that out, actually? Brauer height conjecture. Brauer's height zero conjecture, that's what it is. You're back. Welcome back, Locke. Conjecture modular representation theory relating degrees of complex characters in a Brauer block, and the structure of its defect groups. Proof was completed in 2024. Yeah, so I think that was that person's paper. Let G be a finite group, P a prime, irreducible characters partitioned into Brauer P blocks. Let's go check that out. I forget the exact definition. To each block is canonically associated a conjugacy class of P subgroups of G called defect groups. A set of irreducible characters belonging to B is denoted this. The discrete valuation... So the p-adic valuation. Scored well on probability theory. Hell yeah, Kostaka Corey. Way to go. Way to go. Surely it was all the live streams you've watched. Undoubtedly. Brauer proved that if B is a block with defect group D... then so in other words, this is the number of times that the prime divides the dimension of the E-rep is bigger than the number of times that the prime divides the index here. Okay, so this is interesting because this is yeah, this is also not quite a... Well, no, I wouldn't call this a C. This is more like a sophisticated Lagrange theorem of representation theory. Oh, you're banging your head against infinity categories. Nice. Did you make any progress? Good morning, Arad. How on earth does one get good at numerical analysis? I am the wrong person to ask. I have zero idea. I know nothing, next to nothing about numerical analysis. LeetCode style sites for numerical analysis? Yeah, I have no idea. Nice, yeah, simplicial sets are cool. Simplicial sets are pretty cool. That's about as far as I got in my infinity category learning. I mean, I got a little further, but... I mean, basically, then you understand infinity categories. Oh, good morning, Mom. Thanks for joining. Love you. The height of chi... the height of chi is defined to be the non-negative integer. The height is the difference between these two things. Okay, cool. So Brauer's height zero conjecture asserts that this is true if and only if the defect group is abelian. cool. Oh, and the person I thought was involved in this wasn't actually named here, so that's interesting. Oh, but this is one of the authors. Schaefer Fry, I think. I see. The case of odd primes is finally settled here. Yes, okay, there we go. Yeah, cool. Every damn resource has different notations for the basic stuff, so you had to make your own notes to keep track of everything. Yeah. That's true. Yeah, life just do be like that. I mean, I haven't seen this in infinity categories, but I haven't spent a ton of time with infinity categories. So, I don't know. But certainly I've encountered this kind of thing before. Yeah. Yeah, there's just different notations, and it's one of the skills you need to develop as a mathematician to be able to translate between different notations. Your board say something super funny? No. In fact, I'll probably say something really boring and go over to this paragraph. Oh, nice. Arad coming in clutch. In modular representation theory, well, Maschke's theorem does not hold when the characteristic divides the group order. Brain stalled out for a second. You still haven't mastered regular 1 category theory, let alone infinity. Well, then I guess you gotta keep chugging at the 1 categories. Well, you don't really need to master it before moving on to infinity categories, but yeah, obviously you need to feel some sort of comfort with it. This does not hold when the characteristic divides a group order. The group algebra may be decomposed as a sum of maximal, as the direct sum of a maximal collection of two-sided ideals known as blocks. Yes, Maschke is just being semi-simple. When the field is characteristic 0 or the characteristic coprime, there's still such a decomposition as a sum of blocks, 1 for each isomorphism type of simple module. But the situation is relatively transparent when f is sufficiently large. Each block is a full matrix algebra over F. The endomorphism ring of the vector space underlying the associated simple module. Very good, Leo. You did play with blocks. To obtain blocks, the identity element of the group is decomposed as a sum of primitive idempotents in the center of the group algebra over the valuation ring R of F. Oh, okay. Wait, what's the valuation ring of a finite field? Or are we not assuming F to be a finite field? Primitive? What is primitive? It's not the sum of 2 other idempotents, I believe. For each indecomposable module, there is only one such primitive idempotent that does not annihilate it, and the module is said to belong to or be in the block, in which case all its composition factors belong to that block. In particular, each simple module belongs to a unique block. Each ordinary irreducible character may also be assigned to a unique block according to its decomposition as a sum of irreducible Brauer characters. Okie dokie. I don't know. Should we go read more? Should we go find a book? Should we go find a book on this and read it? Or what? Idempotence or idempotent. I don't know. I have no idea. Idempotence. I think I say idempotent, or sometimes I say idempotent. You can't read, you only write. Damn. Yeah. I don't know. Where do we go from here? Those blocks weren't so useful. Internet died for a second. You can translate between different notations only after you're comfortable with the topic. Well, yeah. Okay. Gosh, I don't know. What are we up about? What's on my thumb? That's another deep question. Did I pull some skin off my thumb or something? Crazy. I don't know. What's Reddit yapping about? What's the math Reddit yapping about? We haven't done a Reddit check in a while. Oh, interesting. Here's when do you think you've gone beyond your abilities? Interesting. Second day in a row, K struggles with FQ join T. Yeah. Locke wants to say infinity category terms? Yeah. Famous mathematicians who hated math? I don't think this can be true. Well, let's see what they're saying. Let's see. Let's see this one first. PhD in stats 5 years ago, didn't go into academia, tried to stay engaged, attending conferences, reading papers, doing research at work that they hoped would be a publication. The funding at work was lost, and tried to keep the research at home. But now I just think things I want to prove as part of the publication would be beyond my abilities. I need more help than I can get by just asking questions on overflow. I'm stuck and don't know how to proceed further. I'm also just tired. Look at the tasks I've laid out that need to be completed and find them very daunting to do alone. I think that I'll write a draft paper along with numerical results I could create more easily. And then I'll have something. Yeah, I mean, probably this person's already had a bunch of replies, but you could write up what you have and put it on archive and then send it to someone. I've actually been thinking about this. I have this idea. It's kind of sort of been done a little bit, but not really in not sort of properly, just in bits and pieces. And so I had this idea to write a paper to sort of formally start the study of something. I'll tell you about it eventually, maybe after the holidays. So I've been thinking about what if I get it to a stage where I make it as more like a review article, plus I have some small new results that I would publish or write up, and some, conjectures. And then I would put it on archive, and then I have some people I would maybe email to, uh, you know, ask what they think it would take to turn it into a paper. So, you kind of do need to master one category theory, which we have not, to keep track of what's going on. Yeah. Yeah. I mean, you need to know, what do you need to know? Adjunctions and limits. I mean, if you got your head around adjunctions and limits, then I think you can start reading infinity categories. You could see a mathematician changing opinions at some point. Yeah, that's true. Yeah. It'd be tough to be that way while doing great works. You want the end lab to stop consuming you? Too bad. It'll never happen. End lab, and to a lesser extent Stacks project, somehow found its way to top results in Google and is doing damage. Oh, I don't know. Yeah, I don't know. The thing is, eventually you get to a point in your life when sometimes NLab is useful, more useful than Wikipedia. That's when you know you've made it. Like, yeah, their references are not very instructive, but so they're probably at the top because a lot of researchers are using them, in part, I would imagine. You could learn with Stacks Project, definitely. And in fact, Stacks Project is probably pretty useful for learning because, it's easy to click back through dependency chains of lemmas. And Yoneda. Yes, that's true. You need to understand Yoneda. And many searches are for references. You guess you'd Google know enough, yeah. Hello, Cole. Glad that you love the videos. You're wondering if I know anything about the exceptional triality automorphism of spin 8. Not a lot. Professor John Smith asks if okay, let me there is this recent triality paper. Yeah, so I guess the idea is something like I'll say something on triality in a second. But yeah, for ChatGPT, I'm gonna, based on the limited information I have about your skill level, Professor John Smith, is I would probably say no. I would say use it sparingly. I've been using AI more and more to help me in my stuff, but the thing is, I still don't think it's very good for students and early learners. I think it's easier for you to get thrown off by it compared to someone that has a bit more experience. Just because if you're more experienced, even though you may not know the topic, you might be better at detecting bullshit from the AI. So that's my only reservation about you using. Well, it depends what you're using it for. Are you using it to help you learn category theory? Probably it's pretty okay for the most part because there's a lot of material on category theory out there. But in that case, just like read a textbook. To be honest, because there's a lot of great textbooks. Yeah, I don't know. But yeah, so the triality automorphism. Yeah, I don't have a ton I can say about it. Right? It's I think this is the Dinkin diagram for triality, and basically this diagram this has several automorphisms that correspond to outer automorphisms, and that links the three groups together of triality. I don't know. Do you have a specific question about it? I don't know if I have a a ton I can say. What's the recent triality and functoriality? Yeah, this is the recent paper about it. We were looking at this before on live stream. Right, what are the three groups that it combines? Yeah, or there's four groups that go into this whole thing. Right, then its outer automorphism group is Z mod 2. Right, because we swap the two, we swap these two in the diagram. Just because the triality automorphism of SO8 cannot be realized, of the Lie algebra cannot be realized on SO8, but only on the simply connected or adjoint form of the group, i.e. spin 8 or PGSO, respectively. Right. Yeah. I don't know what else to say about it. Actually, I want to understand this a little bit better. Learning the growth and deconstruction in one categories is also pretty crucial. Oh, is it? I guess. Fibrations of quasi-categories. I mean, yeah. If one wants to do quasi-categories, right? Isn't that, I mean, that's like one of two approaches. I guess one should learn all the approaches. Yeah, that's another thing. I know I've been talking a lot about plans for videos I'm not gonna, or that I want to do and haven't done them yet. But definitely quasi-categories and fibrations. Fibrid categories and pseudo-functors have been on my mind lately. True. But Wikipedia is a friendlier introduction, I'd say. ChatGPT's factually not there for you, yeah. But it'd be great if it was more reliable. We'll get there sometime, I agree, yeah. Internet died again. You just kind of did random stuff from the textbooks until you gave up and started looking up stuff. Actually, so yesterday I did use AI to 100%. I was screwing around writing some Sage code because I had a friend who was asking. Actually, Leo, by the way, my friend does some like crypto stuff, and I told him about the equation for the Bitcoin curve, and right, and so he, I guess shared this picture of like the elliptic curve, and he was asking, "Oh, it looks like this," and I was like, "Well, no, it's actually over a finite field." So then, I just asked, I almost had all of this. I don't remember what part of this I was struggling with, plotting 2 points at once, but for some reason there was some part of this I was struggling with, and so actually, instead of having ChatGPT fix my code, there's one where you just generate a new cell, right? Or it says generate using AI. And I literally, starting from here, I just prompted it. I said, hey, plot the points for, this prime. And then boom. So here, I think this is the Bitcoin curve over the field with 19 elements. So crazy stuff. So that is what it's good at. Yeah. Well, this isn't the 256. Definitely isn't a 256-bit prime. Who made Barfy face to crypto stuff? Oh, okay, Leo. You're allowed to, I guess. I mean, yeah, it wouldn't be terrible. Yeah, I think it would be good at basic category theory because there's lots of references out there. But then the thing is, so it's like not the end of the world. You could use it sometimes. But I also feel like, what's the point? What's the point if you're trying to learn basic category theory? There's lots of great textbooks. So like, what advantage would AI give you? It's got a small chance of making a mistake and telling you something dumb. I suppose a textbook has that chance as well. Yeah, I don't really see it as a great tool if you're trying to learn some basic thing like that. And if there's something you're trying to do and you're having a hard time finding references for some certain thing, then I don't know, maybe it's more worth using. I don't know. Like I think it's better used for research level stuff. Like that's what I'm using it for. When I query it to try and find, references for some particular kind of result or something. Um yeah. What is triality? Well, it's exactly this relationship. We have this covering of spin 8 covers SO8 covers PG SO8, and then we've got these intermediary. Well, I guess it does it in these three different ways, and somehow this is given to you by the automorphisms of the Dinkin diagram, because this is supposed to connect to yeah. Somehow the automorphisms of the Dinkin diagram correspond to outer automorphisms of your root system. Your understanding is it is because of the vector representation of SO2N. The chiral spinners are that dimension, so when n equals 4, you have 3 non-equivalent representations related by an automorphism. Oh, okay. Okay. Yeah, that makes sense. Next stream you're going to make me do Dinkin diagrams root systems. I mean, I'd have to review it. I've got Sarah's little book. Okay, it's not happening anytime soon, but I was a couple months ago. I was looking at Sarah's little book. Was it Sarah's book? Yeah, I think Sarah's book. No, there's another one. No, there's another small yellow book, I think. I don't remember. But I was thinking about going through that one more carefully. Oh, you're welcome for the videos about SL2Z. It's been a very long time. You just gave your seminar talk and it went well. Hell yeah. Well, we're at infinity categories. Can anyone explain how top can be made into an infinity category? In the simplicial set definition, top is not even a functor, let alone a set to qualify. But Arad says every simplically enriched or topologically enriched category induces an infinity category. I believe it. I don't know how it works, but I believe it. This is covered in the first few pages of higher topos theory. Yeah. Did I put in the prime that Bitcoin uses? No, yeah. Good thing with code is you can verify it instantly most of the time. Can you, though? Can you actually verify anything? Can you verify anything? How do you know you didn't make a mistake in your thinking? How do you know your code only works for the first billion examples? Actually, then I guess it doesn't matter, right? If your code coincidentally gives you the correct answer anytime you run it, and the runtime's like, less than the age of the universe, it coincidentally gives you the right answer, then who cares, I guess. But there is, at the end of the day, there is no verifying proofs. You've prompted AI for some category theory questions, but you do check the answers, yes. Well, let's go look at Keratin. Oh, Well, where? Arad, you just linked us to the entirety of Keratin. What are we supposed to? What are examples of category theories? Infinity categories? Um, Mainly because you're still at the very basics, not comfortable with simplicity enriched category stuff. Only on basic simplicial sets. Sarah's weeny whittle book. Yes, exactly. That's as it's formally known. Depends if the problem is NP or not. Huh? Can I verify verification? No, but I can verify that you can verify verification. Gave up on that book, crucially non-constructively. Gave him on that book instantly because it brushed on simplicial sets like it was basic arithmetic. Yeah, well. And now you did the right thing. You're getting better at simplicial sets. In the end of the day, if you don't know what you're doing, AI won't help you anyways. Yeah. Yeah. Let's see. Infinity category is a simplicial set which satisfies a weak Kahn extension. The theory of infinity categories can be understood as a synthesis of classical category theory and algebraic topology. Two main examples. Every ordinary category can be regarded as an infinity category by identifying C with the simplicial set of boom this construction. Let's go back. Wait, this is just the definition of the nerve, though. Hang on a second. We can identify C with the nerve? What does that mean? How do you identify a category with its nerve? Yeah, I guess you could. I guess it's believable that any one categorical information you could just pass back and forth between the nerve. I don't know. It'll be interesting when AI is good at helping you when you don't know what you're doing. Shortly after that, what it means to understand various areas will change. Yeah. You think in the near future, P sets for higher maths will at least partially be programming projects in Lean? Yeah, I mean, I don't know about the near future, but I believe and hope that that is the case. The functor mapping category to its nerve is fully faithful. I see. Right. Yes. Yeah. The nerve is infinity category. Right. Okie doke. So, right. Where were we? Right. Every Kahn complex is an infinity category. In particular, for every topological space, the singular simplicial set sing dot is an infinity category. Right. But we haven't talked about simplicity enriched yet, right? If math is to avoid its own replication crisis, we'll need lean type standards. Yeah. Beware that, individually, both of these examples are rather special. An infinity category can be regarded as a mathematical structure which encodes information not only about objects and morphisms, but also homotopies between them. Right. In the nerve of an ordinary category, homotopy is trivial. Right. On the other hand, if C is a Kahn complex, then every morphism is invertible up to homotopy. From a category theoretic perspective, this is very restrictive. Yes, but we like our groupoids, don't we? Simplicial categories are in 2.4 if you want that specifically. Okay. Should we go jump over? Should we go over to simplicial categories? Maybe. Actually, we should probably end stream. Oh, good morning. Ken just dropped in, and here I am talking about ending stream. Yeah, I don't know. I feel like I've not been my most productive self lately, so maybe I should try to keep the streams shorter and try to force myself to get to work earlier. I don't know. You just specifically want to figure out the construction with weak equivalences to infinity categories. Specifically just top to infinity categories. Dwyer-Kahn localization, aka hammock localization. Is this in Keranin? What about arbitrary oriented manifolds categories? What does that mean? Have fun proving lots of theorems. I will, and you too. And you too. Yeah, I think I'm gonna jump off now for today. And would enjoy talking about how one can interpret modular forms as section of line bundles. Yeah. So maybe I'll make a video on that point, but maybe we'll look at that in tomorrow's office hours. Someone remind me if I forget. Okay.